Okay, so there's our drawn components. The footprint of the pins, the I/O pins, the connectors, are already done because it's predefined. And you'll notice it's green. Now what green means is that it's already got the footprint, and it means that you can't redefine it. That's what it means. But you'll notice that on the resistor, we'll start on the resistor first. On the resistor, you'll notice that it's black in colour, right? It shouldn't be black in colour, it should be blue. Now what blue indicates is that it has a footprint. In other words, multi-sim knows what size to put onto the PCB. Okay? So how do we do that? This is the one that gets everyone every single time. This is a complicated set of manoeuvres, so we'll take our time with it, okay? Once you've done it once, twice, 3 times, it's easy, but the first time is quite hard. I want to get a footprint for R1, so zoom in a bit so we can see what we're doing. I'm going to click on R1, quite logically really. So now it's highlighted, means I'm interested in it, the software knows that. And I'm going to right click, yeah, and I'm going to scroll right to the bottom where it says properties. And I'm going to click on properties. Yeah? Straightforward so far. It's just memory, muscle memory, that's what you do. So click on it, right click, go to properties. Often when I'm trying to learn things like this, I find it useful just to write down on a piece of paper what the sequence of events are. So highlight component, right click, properties. You don't need to write anything else down, it's just a sequential order of it. Inside there, here, there's a whole load of things about the package that you don't really need to know. It's just describing the resistor, temperature coefficients, all that kind of stuff. We're not going to adjust those because they're pretty much universal in that work, so we'll leave those alone. But what I want to do here is I want to click on Edit Package. Inside Edit Package, I've got another series of options there. It tells me a bit about the component, it tells me it's got 2 legs, it tells me it's one single entity or one object, and I don't want to do anything else apart from select from database. So now what I'm starting to do is I'm going to go into the database and I'm going to tell it what the footprint is. The magic information that the PCB maker needs to know. Okay? So select from database, and now we're in the realm of things that are interesting. So you can see I'm looking at footprints now. And I can scroll down these footprints and I can find lots and lots and lots, literally tens of thousands of different footprints. Literally. And you'll notice you've got columns here, manufacturers, package numbers, SMT, TH, pinout counts. It's enormously complicated. So we're now looking for a needle in a haystack. You know that expression. It's actually quite easy to find a needle in a haystack. You know how? Isn't that? It's dead easy to find a needle in a haystack, but only if you've got the technology to do it. And that's where we are here. So we've got the technology to find the thing that we're looking for here. Now, what's one of the first things we know that we want through-hole technology, right? We know that. That's a given to us. So if we go up to the right-hand corner here and it says filter. So what we're going to do is we're going to take the entire database, every footprint that we know, and we're going to run a filter on it. And the first thing that we're going to filter against, so we get this come up, just like this blank window, and here we want to do add row. Okay? So on that add row, what we want to look for here is we want to get rid of everything that isn't through hole. That will be the first thing that we do. So if we look here, we've got SMTTH equals, and the value we're looking for, we want to find TH. So that's our filter. So, TH, yeah. So that's our filter. We're looking at everything, but we only want it to return things that have TH written.
Okay.
And look what we've done now. So our filter, if we look in this column here, everything has TH in it. Everything. So we've just made the database considerably smaller. But there's still lots and lots, tens of thousands of components that have got through whole technology. So the next thing we want to do is to turn another filter on, only this time, so we're going to add a row again. This time we want to go to package, because it's the package we're interested in. We don't want equals, we want contains, and in here we want the word res, the resistor, okay? It's the same for looking at the capacitor as well. So now if I do that, and I say, okay, look what I've got now. So you'll notice that the number of packages I've got is only 11 now, previously from over 100,000. So now I've only got 11 packages down here. Now I can scroll through and see which one I like the look of. Okay? Yeah, and you can see that they're all through whole technology. Look at the picture on the bottom right hand corner. They're all through whole technology, but they're all slightly different sizes. All slightly different sizes. Now, actually selecting the component, I'll let you come up to speed. It's that filter. It messes everyone up, unfortunately, isn't it? But without the filter, you will look for hours for the component you're trying to find. But after a while, and I'll show you a little trick in a minute where you can save that. You don't need to be doing it over and over again. Okay, so I've now got 11 resistors on there that all use through hole technology. There are others. So one of those must be for me, right? Yeah? I want one of those for my printed circuit board. But how do I know which one? Well, if you look here, look, it says res 1300, 700 by 250. What does that mean? Well, the Americans are awkward people and they don't use metric like the rest of the civilized world. They use strange measurements called thous, which are thousandths of an inch. The numbers referred to in multisim are thousandths of an inch. So that is, that top one there, is 700 thousandths of an inch, in other words 0.7 of an inch. And the other dimension is 0.25, which is a quarter of an inch. And you can see that you've got different dimensions as you go down here. Now on these, it doesn't make a lot of difference which one you use, because they're all relatively small. You don't want the ones at the end, because they're that one, because it's quite big. I would recommend the 800 by 250. But you're not committed to it, because you can change it when you export to your PCB if you don't like it and you want it bigger or smaller. But that's what those measurements mean. Yeah? And when you buy components, because that's what you do in the workplace, so you don't just go out and say, can I have 100K resistors, because the suppliers will say what size. So that's where your critical moment, and that's really where your Google searches come in and everything. You've got to be sure about what it is that you're buying, what the dimensions of the package are, and everything. This is donkey work. This is hard work, time consuming, but it's part of the design process. Once you've done it once, you've got a drawer full of components of a particular size, like quarter watt or whatever. They're the only ones you're going to use. Okay, so I'm going to select the second one down. I like the look of that one. It's a nice one. So I'm going to select that. Yeah. So I've selected him, and that window back here, so I've done the select from database, so I can just OK that. And everything's done there, I can OK that. Look what's happened there.
Has blue.
It's turned blue, which means Multisim knows what the footprint is. And it's quite a long, protracted way of doing that, but let's have another go for the capacitor now, shall we? So let's have a look at the capacitor. Remember left click right, properties, inside properties, edit package, select from database, and you'll notice at the top here I've got master database, which is where I am at the moment, but I've also got a user database. Now I could have put my resistor in there, but I forgot, but I'll try and put the capacitor there this time. So, we know it's a capacitor, we know we want through holes, so let's turn on the filter. Add a row, and inside here, SNTTH equals, and we want it to be TH. So as before, we should have, everything is now TH, which it is, which is good. So now we're going to run another filter, and this time we're going to add another row, only this time we're going to say package, contains, that's right, and it contains the word cap. CAP, because it could say capacitor, it could say cap 01492, it could say 01 cap 37S, but it's always going to have that word in there that we're looking for. So now if we run the filter there, you'll see that all of these are now through hole, and they're all capacitors. And there's more of them, there's 68 of them, but you can clearly see that probably we don't want an electrolytic one like we had up there. So we need to choose one of these, and we've got the dimensions, they're the same as we had before, so that's a fairly small capacitor. My filters have gone wrong, yes, and that's because bear with me, I clicked the back button. I've done something stupid here, I'll be with you in a second. So I'm just doing the same as I did before because I made a mistake. Okay, so I've got my filters on. So I've got cap 1, cap 2, cap 3, cap 4, cap 5. They're the normal ones which are sort of like this. So you get to hold up capacitors up about 100 nano, will you? Hold up a couple of capacitors out the drawer. About 100 nano, something like that. So that's a 10 nano, that would be cap 1. Pretty small one. Shane's going to show you a fairly typical size filter in the capacitor, 100, 200 nano, something like that. So that would be cap 2, cap 3, something like that on there. So you get the idea. So I'm holding pretty much as small as they go, and they're a pretty reasonable size for a capacitor. Okay, so let's choose, in this particular case, let's choose which one do I like to look at. I like to look at cap 3. You make your own choices. Now, before I do this, what I can do, you see down the bottom there, so don't put select yet, do copy to. Yeah, and you'll see here that you've got the corporation database, but you've got one here called your user database, which means next time around, if you want to put the capacitor down, you know what the footprint is, you can just pull it out of your user database and all hard work's done. There's no filters, nothing. It's already there. Yeah, because you've stored it, so you've got readings. Yeah. So I'm just going to do that. So it's now my user database, and I can use it in the future. Same as before, select, OK. The capacitor's gone blue. Isn't that great? You okay?
Yes, sir.
Fantastic.
So every time we copy to the user database, and every time we create a new component, we just snap it from our user database.
It doesn't take it from the main database, so that it's a copy into your user database. But the next time...
Oh, we have to set it again to the... we have to set a footprint again. Oh,
You only need to copy it once, so the next time, next time you right click on a capacitor and go to properties, you can just select the footprint directly from your user database rather than having to look for it in the main database. Because your database is only going to have a few components in, whereas the main database is going to have 150,000 components in. So that's more difficult to find, yeah? So it's much, much easier if you store it in your local one.
Is the footprint specified only for the 1K resistor and the capacitor, or if
No, you can change the value. When you're producing the printed circuit board, the fact that it's 1K is absolutely irrelevant because the printed circuit board we don't simulate. So we just see what it looks like. We can solve whatever we want in there. It's the same with the boards I've given you. It says put a 1K in there and you put a 1 megaohm and 1 million ohm in there. It doesn't make any difference. It's still going in the same holes. So the actual value on here has no relevance to the printed circuit board. Apart from the physical size, so if it were a 1 ohm resistor, it would be big because it has to display the thing. But that's a separate argument.
Sir, I don't understand the serious filter part. For this, is the average I mean, do you use the same footprint to
No, because you need to know a little bit about your component. So the resistor I've selected is one of the smaller ones, but if I wanted to have one that had more power situation, that's bigger. So you would choose a different one, but that's what those numbers tell you, because those numbers are in microns, thousands of an inch. So what you can do is if you've got some calipers, which you have, you would put the calipers across there, measure it in microns, and then you could select the one you want